Hello everyone. The mission to moon or the Chandrayaan projects of our country are a matter of pride because we are the fourth nation to have put a lander or a spacecraft onto the surface of the moon. The countries which have sent missions to moon are US, USSR, China, Japan, Israel, United Arab Emirates, France and our country. Manned missions have been sent by US, which have sent 6 missions which have been successful, 9 unmanned missions by USSR, and a matter of pride, our nation has been the first one to put a landing craft and a rover onto the moon in the first attempt. Till now, we have had 2 Chandrayaan missions and the third one is in the pipeline. The Chandrayaan mission was conceptualized in 1999 during a conference in the Indian Academy of Sciences, and after that about 100 scientists got together, put their brain. They were basically space scientists, astrophysicists, physicists and people dealing in this field who conceptualized this complete mission and was put up to the government and got its approval in 2003, and it was announced on the Independence Day in August 2003 by the erstwhile Prime Minister Atal Bihari Vajpayee. This was an unmanned mission and the aim and objective of the mission was to study life on moon, soil structure, the gases present, the water and the type and availability of other kind of things which can be there. Aim was to take pictures and send it to Earth for further studies. Chandrayaan-3 was the first Indian lunar probe under the Chandrayaan program. It was launched by ISRO or Indian Space Research Organization in October 2008 and it operated till August 2009. It included a lunar orbiter and an impactor. The spacecraft used was PSLV-XL and it was launched on 22nd October 2008 from Satish Dhawan Space Center at Sriharikota. This mission was a major boost to India's space program as India researched and developed indigenized technology to explore the moon. The vehicle was inserted into lunar orbit on 8 November 2008. The estimated cost of the project was 386 crore rupees or 48 million US dollars. It was to survey the lunar surface for over a period of 2 years to completely map the chemical composition of the surface and get a 3D topography of the moon. The polar regions are of special interest as they might contain water ice. Among the many achievements of the discovery of the widespread presence of water molecular in the lunar soil, there was a discovery of finding ice water in the various regions of the moon. This mission basically sustained for 312 days and had to be called off before its life because it started having technical snags. And this mission was officially called off on 28th of August 2009. The specifications of the lunar orbiter was about 1080 kgs and was cuboid in shape. It had an X-band communicator with a gimbaled parabolic antenna for payload data transmission. The spacecraft used a bipropellant integrated propulsion system to reach the lunar orbit. The power plant consisted of one 440 Newton engine and 8 22 Newton thrusters. The fuel and oxidizer was stored in 2 tanks of 390 liters each. This craft was 3-axis stabilized with 2 star sensors, gyros and 4 reaction wheels. The craft carried 12 redundant bus management units for altitude control, sensor processing and antenna orientation. Here it is very important to know the kind of payload this mission carried. It had Indian payload and also foreign payloads, which is a matter of pride. It had the terrain mapping camera, the hyperspectral imager, it had the lunar laser ranging instrument, the high energy alpha Juliet gamma or an X-ray spectrometer and a moon impact probe. These were from our country, and other countries sent up an X-ray fluorescence spectrometer, a subkinetic velocity atom reflector analyzer, a moon mineralogy mapper, a infrared spectrometer and a mini SAR which was designed by NASA, and a radiation dose monitor experiment. The sequence of the orbit burns were basically after takeoff. It went into a first orbit burn and then the second orbit burn took place on 25th October 2008 and subsequently the third orbit burn was carried out on 26th October 2008 at a different time frame. And the final or the fourth orbit burn was done on 29th October 2008, and with the fifth and final raising maneuver which was carried out on 3rd November 2008, the spacecraft's engines were fired for about 2.5 minutes, resulting in the Chandrayaan entering the lunar transfer trajectory and at an apogee of about 380,000 kilometers went into the moon's orbit. And slowly then the orbit speeds were reduced and brought into control, and as it started orbiting the moon, it was made to land onto the moon with retrograde technology or jets which decreased the speed, and the lander landed onto the surface of the moon with the rover coming out and started taking pictures and samples. While on moon, it did about 70,000 image acquisitions, mapped minerals, detected X-ray signals which were of aluminium, magnesium and silicon and various other materials that were there. It also took a full image of the Earth which was revolving. After having sent these images, there were problems in communication with the orbiter, and on 22nd of October 2008 the mission was called off. The orbiter was supposed to be in the lunar orbit for about 1000 days after that, but then it was still in orbit till recently, sometime back, it was crashed into the lunar surface. The team of the Chandrayaan-3 consisted of G. Madhavan Raya, T.K. Alex, Mil Swami Annadurai, S.K. Shivakumar and many more others who were linked with the project. After the Chandrayaan-1 project finished off, India's ambitions did not finish and Chandrayaan-2 was announced. This consisted of a lunar orbiter a lander and a Pragyan rover, all of which were indigenized. Initially, the Russians were to collaborate to make the rover and the lander, but Roscosmos, the firm of Russia which was to fabricate it, could not deliver it timely and the timelines were shifted out. So, India took on the onus and indigenously made the Vikram lander and the Pragyan rover on its own. The objectives of this mission were also to study the soil surface, to see the presence of water, mineral mapping, images of Earth, and related studies. The spacecraft was launched for its mission on the 22nd of July 2019 from the Satish Dhawan Space Center in Andhra. The craft reached the moon's orbit on 20th August 2019 and began orbital positioning maneuvers for the landing of the Vikram lander. The lander and the rover were scheduled to land on the near side of the moon in the south polar region at a latitude of about 70 degrees south on the 6th September 2019 and conduct the scientific experiments for one lunar day, which is approximately 2 Earth weeks. However, the lander crashed when it deviated from its intended trajectory while attempting to land on 6th September 2019. According to a failure analysis report submitted to the ISRO, the crash was caused by a software glitch. For some time, communication was tried to be rebuilt with the lander, the orbiter, but it was not successful and we had to call off the mission, and right now we are preparing for Chandrayaan-3 as the moon mission is not over. Presently, the date for the Chandrayaan-3 launch is in July this year, and this is basically a follow-up mission to the Chandrayaan-2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of a lander and rover configuration. It will be launched from the Satish Dhawan Space Center, Sriharikota. The propulsion module will carry the lander and the rover configuration till 100 kilometers of the lunar orbit. The propulsion module has spectropolarimetry of habitable planet Earth payload to study the spectral and polarimetric measurements of the Earth from the lunar orbit. It will have thermophysical experiment items, instrumentals for measuring lunar seismic activity. Then it will have the probes to estimate the plasma density and its variations, a passive laser retroreflector array which will be accommodated for lunar laser ranger studies. It will have an alpha particle X-ray spectrometer and a laser inducted breakdown spectrometer in the rover. It is basically an indigenized lander module, a propulsion module and a rover with an objective of demonstrating new technologies acquired for interplanetary missions. The main aim of this mission will be to carry out soft landings onto the moon, movement of the rover, and carry out photograph or image acquisition, and finally take samples for analysis. And thereafter we have also the Chandrayaan-4 and 5 missions in the pipeline. So let us wish ISRO all the best for its future moon missions, which places our country on a very high pedestal. So please like, share and subscribe to our channel to know more on such events. Jai Hind.